An electric heater of resistance 40 ohms is connected to a 200-volt supply for 5 minutes. Calculate the electrical energy consumed. An electric heater of resistance 40 ohms is connected to a 200-volt supply for 5 minutes. Calculate the electrical energy consumed. So the first thing I would want to do here is to bring out the parameters. So the question is an electric heater of resistance 40 ohms. So the resistance is equal to what? 40 ohms, right? The resistance is equal to 40 ohms. Is connected to a 200-volt supply. So the potential difference V is equal to what? 200 what? 200 volts for 5 minutes. So the time is equal to what? 5 minutes, right? And you should know that the SI unit for time is what? Seconds and not minutes. So we know that 60 seconds is equal to what? 1 minute. So therefore 5 minutes will be equal to 5 times 60, and that will give us what? 300. So my 5 minutes is equal to what? 300 seconds, right? Calculate the electrical energy consumed. So what I'm looking for is the electrical energy, which is the same as the work done. So that is what we're looking for. So what is the formula for work done, or what is the formula for electrical energy? Formula for electrical energy is equal to IVT, right? IVT. W is equal to what? IVT. So I have T, and it is given as what? 300 seconds. I have V, which is the potential difference. It is given as what? As 200 volts. I have I here. There is no I here. So what I have is what? R. So I'm going to look for the value of I. So from Ohm's law, I know that V is equal to what? IR. V is equal to IR. So if V is equal to IR, to make I the subject of the formula, I will divide both sides of the equation by the coefficient of I, which is R. So this is divided by R, divided by what? R. So that this R can cancel out this R. So my I will be equal to V over what? R. So what is my V in this question? My V is what? 200 volts, right? 200 volts over the R, which is the resistance, is what? 40 ohms. So 200 divided by 40 will give me what? 5. Will give me 5. So my current is equal to what? 5 ampere. So since I have I to be equal to 5 ampere, I cannot look for the work done, right? So W is equal to IVT. So what is my I? My I is 5 ampere. 5 times, what is my V? My V, which is the potential difference, is what? 200 volts times 200 times, what is my time? The time is what? 300 seconds. So times 300. So if I multiply this will be equal to 5 times 200 times 300 is equal to 1, 2, 3, 4, 5, right? Is equal to 300,000. So that is equal to 300,000 what? 300,000 joules, right? This is the electrical energy that is consumed, 300,000 joules. So I can also convert it to index number. So this is 3 times 10 raised to the power of what? How many zeros are here? 1, 2, 3, 4, 5. So this is 3 times 10 raised to the power of 5 joules, right? This can also be written as my answer. So this is the work done, which is the same as the electrical energy, right? It's quite simple and straightforward. It's very important that you should know your formulas, that W, which is the work done, is equal to IVT, and also know your Ohm's law formula, which is V is equal to IR, right? Know this formula as well.